Hello, hi friends, good morning to everyone. So here, Department of Collegiate and Technical Education, Bangalore, Department of Automobile Engineering. So this is the fifth semester subject, that is Design of Machine Elements. On this topic, I am going to teach some topics, that is Design of Simple Machine Parts. Under this subject, unit number 4, that is chapter number 4, Design of Simple Machine Parts. So here in last session I have covered the theory of knuckle joint, the design procedure of knuckle joint, and I have solved the some problems. Okay, so here this is the last session, that is 14th session. So here in this session I am going to solve one more problem, that is problem on knuckle joint. Okay, so now let us start. So what is the actual problem and what are the given data? So what are given in the problem? So let us understand, and we have to take the data clearly. Okay, so here what are the actual contents in this topic that I am going to solve it. Okay, so here these are all the contents. So first one is some solved example on design of knuckle joint, and MCQs are also here in this content, that is multiple choice questions and references. Okay, so now, so first problem is, so already I have solved one problem. So here this is the one more problem that I am going to solve in this session, that is session number 14. So here the problem is like this: design a knuckle joint to connect two MS rods subjected to an axial pull of 100 kN. The allowable stresses for rods and pin are 1 into 10 to the power of 5 kN per meter square, 1.3 into 10 to the power of 5 kN per meter square, 0.60 into 10 to the power of 5 kN per meter square in tension, crushing and shear respectively. The bending of the pin is prevented by selection of proper fit. So here this is the actual problem. So actually what are the given data? So let us understand first. So read the question carefully once again. So here pull is given. So pull is nothing but load. So load is denoted by capital P. Therefore capital P, that we have to take it, P is equal to 100 kilonewton. So here we have to convert it into Newton. So that is equal to P is equal to 100 kilonewton, that is equal to 100 into 10 to the power of 3 Newton. Okay. So next, the allowable stresses for the rods and pins are given here. So that is tension, crushing and shear stresses are given in the problem respectively. First one is the tension, that is tensile stress. So therefore sigma T indicates tensile stress, that is equal to 1 into 10 to the power of 5 kilonewton per meter square. So here, so 1 into 10 to the power of 5 into kilo means 10 raised to 3 into Newton per kilonewton per meter square. But actually here this is the data, but we have to convert it into Newton per mm square. Therefore again you have to multiply it by 10 to the power of -6. So after simplifying all this, you will get 1 into 10 square. So that is equal to 100 Newton per mm square. So that is called as what? Tensile stress of the rod. Okay. So here shear stress is also given in the problem. Shear stress means, so shear stress, it is that is tau. Tau is the symbol of shear stress. So tau is equal to 0.6 into 10 to the power of 5 kilonewton per meter square, but we have to convert it into Newton per mm square. Therefore 60 Newton per mm square. After simplifying it, we got the value, that is 60 Newton per mm square. So this is the value of shear stress, that is tau value. Okay. So next, crushing stress, one more stress, that is crushing stress. So it is denoted by sigma C. Therefore sigma C is equal to 1.3 into 10 to the power of 5 kilonewton per meter square. So therefore So it is given in kilonewton per meter square, but we have to convert it into newton per mm square. Therefore, after simplifying it all, you will get sigma c. Therefore, sigma c is equal to 130 newton per mm square. Okay, so these are all the given data. Okay, so next for this problem we have to refer DDHB, that is Design Data Handbook. So here there are 8 parameters or 8 steps are very important to make a design or for the design procedure for the knuckle joint. So first one is the very first step, that is failure of the solid rod in tension. So this is the first step of design procedure of knuckle joint design. Okay, so here failure of solid rod in tension. So here, so there is a there is a formula which is already printed or which is available in DDHB, that is page number 67, wide equation 4.19a. So that is load is equal to, what is the formula? Actually we know the basic formula, stress is equal to load divided by area. Therefore load is equal to area into stress. Therefore area is equal to load is equal to area into stress. So load P is already given in the problem, that is 100 into 10 to the cube. Okay, so that is equal to area. Area means what? Area of the solid rod. Therefore pi divided by 4 into d square into 100. So that is sigma t is equal to 100, which is already given in the problem. Therefore in this equation we have to calculate d. Therefore we have to take d square outside, and after simplifying it, finally we will get this value, that is diameter of the rod. So very first step we have to find out d value. After that we can get d1, d2 and c value, b value, d value, e value and f value after getting only d value. So now we got the d value, that is diameter of the rod. So d is equal to 36. So it has come only by applying this formula. We get this value, that is d is equal to 36 mm. Okay, so next other dimensions of the knuckle joint are by referring the DDHB, diameter of the knuckle pin, that is small d1. So that should be equal to small d. So therefore small d1 is equal to small d. So that we have already found out, that is d value, that is 36 mm. Therefore d1 is equal to d, that is equal to 36 mm. Next, outer diameter of the eye, that is capital D. So capital D is equal to empirical formula which is already available in DDHB. Now what I have explained in the last problem and the design procedure of knuckle joint. So therefore capital D is equal to 2D. So D already we have calculated d value. Therefore 2 into 36 you will get 72 mm. Next, diameter of the pin head and collar, C value. So C value means, so here actually in this procedure we have to calculate first B, C, D, E and F. After finding all these we can design the knuckle joint procedure. Okay, so here diameter of the pin head and collar, that is capital C. So capital C is equal to empirical formula 1.5D. Therefore 1.5 into D means 36. By multiplying these two, that is 1.5 into 36, you will get 54 mm. Okay, so next, thickness of the collar pin head, that is capital E. Capital E is equal to, what is the empirical formula here? E is equal to small d divided by 2. So small d means already calculated value, that is 36 divided by 2, you will get 18 mm. So now E completes. Next, thickness of the fork. Thickness of the fork means that is, it is denoted by capital B. So that should be equal to 0.75D, because this is the empirical formula which is available in DDHB. Therefore 0.75 into small d means what? Small d, it is nothing but small d is nothing but actually 36, but it is wrong printed. So after simplifying it, you will get a capital B value. Okay, thickness of the single eye or rod end, that is capital F. So F is equal to 1.5D. Therefore 1.5 into 36, you will get 54 mm. Okay, so here instead of 24, make it as correction 36, so you will get 54 mm. Okay, so next failure of the knuckle pin in shear. So that is the second step. So actually failure at a rod, so that we have find out. Second step is failure of the knuckle pin in shear. Okay, failure of the knuckle pin in shear, failure of the knuckle pin in yes, only the failure of the knuckle pin in shear, not in tension, as well as the crushing. So failure of the knuckle pin in shear. So what is the formula actually? So here load is equal to area into stress. Okay, so in multiplied by 2, because the shearing effect is at two sides. Okay, so that is P is equal to area into stress into 2. Therefore this equation is available in DDHP page number 67, wide equation 4.20a. Okay, so therefore P is equal to, capital P is equal to pi divided by 4 into d1 square into stress. Which type of stress he is applying here? Because failure of knuckle pin in shear, therefore we have to apply the shear force or shear stress value, that is tau into 2. Therefore, so in this equation we have to calculate tau value again, even though it is given in the problem. Cross verification and cross checking, we have to take it as outside, and we have to find out the tau value after applying a P value, that is 100 into 10 raised to 3 divided by area, that is pi divided by 4 into d1, means d1 is equal to d value, so that is 36 whole square into 2. So after simplifying it, you will get 49.12 Newton per mm square. So here this is the tau value. Okay, but actually in the problem what he has given 60 Newton per mm square, but it is induced shear stress of the knuckle pin. What we got the value, that is 49.12 Newton per mm square, but what is the permissible value? That is 60 Newton per mm square. Hence it is less than the permissible value, hence the design of the knuckle pin in shear is safe. Okay, so now let us check the failure of the single eye or rod end in tension. Okay, so this is the third step with respect to the equation. So this type of equation is also given in the problem given in the DDHP page number 67, wide equation number 4.21b. So what is the equation here? Load is equal to area of the single eye into concerned stress, that is sigma t, tensile stress. Therefore what is the area? So area is equal to capital F into bracket capital D minus small d1. So this is the area into tensile stress, that is sigma t. Therefore, so what we have to calculate here? So sigma t. So sigma t is going to be calculated here. Okay, so sigma t we have to take it as outside, and sigma t is equal to P divided by F into bracket D minus D1. Okay, so therefore by substituting all these values, finally we get sigma t value. So that is equal to 51.44 Newton per mm square. So here it is less than permissible value, that is 100 Newton per mm square. Hence the design of single eye or rod end in tension is safe. Okay, so next coming to discuss about the fourth point, that is failure of single eye or rod end in shear. So what is the formula actually here? P, so that is load is equal to area of the single eye into shear stress, because failure of single eye in shear, therefore we have to apply tau value. Therefore tau value, that is shear stress, that is going to be found out. So therefore we have to take it as outside. Therefore tau is equal to load divided by area. Therefore P is equal to 100 into 10 to the power of 3 divided by 54, because it is F value 54 and D value 72 and D1 value 36. By simplifying it, finally you will get 51.44 Newton per mm square. So this is the induced shear stress of the single eye, hence it is less than the permissible value. So what is the permissible value here? 60 Newton per mm square. Hence the design of single eye in shear is safe. Okay, so now let us understand the fifth parameter or fifth step, that is failure of the single eye or rod end in crushing. Okay, so failure of single eye or rod end in crushing. So what is the formula here? Load is equal to area into crushing stress. Therefore P is equal to, area means F into D1 into sigma C, because crushing stress is going to be applied. Therefore here in this formula we have to calculate sigma C. So this type of formula is available in DDHP Design Data Handbook, that is page number 67, wide equation number 4.21c. Therefore what we require here, so we require sigma C value. Therefore we have to take it as outside. Sigma C is equal to capital P divided by F into D1, small d1. Therefore what is P value here? P means what? Tensile load, that is 100 into 10 cube divided by F value is nothing but 54 into D1 means 36. Therefore sigma C is equal to 51.44 Newton per mm square. So hence this is the induced crushing stress of the single eye. Hence it is less than the permissible crushing stress of the single eye, that is 130 Newton per mm square. Hence the design of the single eye or rod end in crushing is safe. Okay, so now I am going to discuss the one more point, that is step number 6, failure of the forked end in tension. So what is the formula? So here load is equal to area into stress. Okay, so load is equal to area of the forked end into tensile stress. Therefore P is equal to 2 times, because forked end is having two eyes, one is at upper side and another one is at lower side. Therefore it should be multiplied by 2. So therefore 2 into area of the forked end, that is outer diameter and inner diameter, capital D minus small d1 into capital B. So into bracket capital B into sigma T. So sigma T means what? Tensile stress. So by applying this formula, this formula is already available in a DDHP, that is Design Data Handbook, wide page number 67 and equation number 4.21a. Okay, so here in this equation we have to calculate sigma T, that is induced tensile stress of the forked end. Therefore sigma T has to be taken outside. Therefore sigma T is equal to load P divided by 2 into bracket capital D minus small d1 into bracket capital B. Therefore now you can substitute all values in this equation. Finally we will get a sigma T, that is tensile stress of the forked end. Okay, therefore 51.44 Newton per mm square. So this is nothing but what? Tensile stress of the forked end. Okay, that is induced tensile stress of the forked end, that is equal to 51.44 Newton per mm square. So what is the permissible value? 100 Newton per mm square. So hence this is less than the permissible value, that is induced tensile stress of the forked end is less than the permissible value of the forked end. Therefore design of the forked end in tension is very safe. Next I am going to discuss about the last but one point, that is failure of the forked end in shear. Okay, so what is the formula? Load is equal to area into concerned stress. So what type of stress is going to be applied here? That is shear stress. Therefore load is equal to area into B into tau. So tau means what? Tau means shear stress of the forked end. Therefore what we require here, what we are going to find out, that is tau value, that is induced shear stress of the forked end. Okay, that we are going to find out. So therefore we have to take it as outside. Therefore tau is equal to this divided by all this. So capital P, that is load, 100 into 10 raised to 3 divided by 2 into D minus D1 into bracket B. So that is, therefore by substituting all values, like P is equal to 100 into 10 raised to 3 divided by 2 into bracket capital D means 72, small d1, that is equal to D value. So that D value is nothing but 36 and close the bracket into B value, that is 27. by simplifying it, you will get this value, that is induced shear stress of the forked end, that is equal to 51.44 Newton per mm square. It is less than the permissible value, that is 60 Newton per mm square. Hence, the design of forked end in shear is safe. So last point is failure of the forked end in crushing. Okay, so here what is the formula here? Load is equal to area into concerned stress. So what type of stress is going to be applied here? There is crushing stress. So crushing stress is denoted by sigma c. Therefore capital P is equal to 2 times of B into small d1 into sigma c. But here in this equation, what we are going to find out? So sigma c is going to be found out. Therefore we have to take it as outside, that is sigma c is equal to this, that is capital P whole divided by 2 into B into d1. Therefore now you can substitute all values in this equation. Finally you will get sigma c value, that is sigma c is nothing but induced crushing stress of the forked end. So that is 51.44 Newton per mm square. Hence it is less than the permissible value. So what is the permissible value here? 130 Newton per mm square. Hence this is less than this value. Hence the forked end failure design of forked end in crushing is very safe. So from the above design, the induced stresses are less than given permissible value. Therefore the design of knuckle joint is safe. Okay, so now it completes the entire problem. Okay, so now I am going to discuss about the multiple choice questions, MCQs. So here, what is the first question here? Outer diameter of I, that is capital D. So capital D is dash. So there are 4 options. So A option is D, and second option 2D, third option 3D, and fourth option is 4D. But here outer diameter of the I, that is capital D. So by empirical formula, capital D is equal to 2D. Therefore the right answer, that is second one, B is right answer, that is outer diameter of the I, capital D is equal to 2D. So this is the right answer for the question number 1. So now second question, thickness of the single I or rod end, that is capital F, is dash. So first option is D, second option is 1.5D, third option is 1.5D, and fourth option is 2D. So what is the actual right answer here? Thickness of the single I, that is F. So F should be equal to 1.5D, that is empirical formula. So this is also available in DDHB. Okay, so here this is the right answer, that is C is the right answer for the question number 2, that is capital F is equal to 1.5D. Okay, so next, what is the third question here? Thickness of the pin head and collar E, capital E. So what is the E value, or what is the empirical formula for E? So okay, so what is the right answer here? There are 4 options, that is D by 2 and D by 4 and D by 6 and D by 8. So that is D by 2 is the right answer, that is A is the right answer for question number 3. So now let us see the fourth question. What is the fourth question here? Diameter of the knuckle pin head and collar C. So C is equal to, what is the empirical formula for C? So C is equal to, there are 4 options, that is 0.5D and 1.75D and D and 1.5D. So these are all the answers, but actually right answer is C is equal to 1.5D. So this is the right answer, that is D is the right answer for question number 4. Next, for the question number 5. So what is the question number 5 here? Failure of the rod in tension, that is P is equal to area into sigma T, that is stress, which P is 100 kilonewton and sigma T is 100 megapascal, and D value. So we have to find out D value by using this equation. So after substituting the values and values in this equation, finally we get D value, that is the fifth question. For the fifth question, A is the right answer, that is 36 mm. So D value is equal to 36 mm. This is the right answer. Okay, so next problem number 6. what is the problem here, or what is the question? That is sixth question. Failure of knuckle pin in shear, P is equal to area into shear stress into T into 2. So when P is 100 kilonewton, D1 is 52 mm, then you have to find out toe value for the for applying this formula, and by substituting all values, finally we will get toe value. That is, the right answer is B answer, that is 49.12 Newton per mm square. So this is the right answer for the question number 6. Okay, these are all the dummy answers, but B is the right answer for the question number 6. And last but one MCQ, that is failure of I or rod in tension, that is P is equal to F into bracket D minus D1 into sigma T, and P is 100 kilonewton, F is 54 mm, and D is 72 mm, D1 is 36 mm, then sigma T. So we have to find out the sigma T by applying all these values in this equation. Finally you will get a sigma T. So what is the right answer? Let us see here. So 21.4. No, it is not right. It is not right answer. It is also not right answer. This is also not right answer. I think it is the right answer. That is D. That is the fourth option. 61.44 Newton per mm square. This is the right answer for the question number 7. Okay. The next, what is this question number 8? Failure of I or rod in shear. P is equal to F into bracket D minus D1 into toe. When P is 100 kilonewton, F is 72 mm, D is 72 mm, D1 is 36 mm, and toe value. So by applying all these values in this equation, finally you will get toe value. So what is the right answer for all these answers? So here this is the A answer is like this, B answer is like this, C answer is like this, D answer is like this. But among A to D, all these, so these are the 3 dummy answers, and this is the right answer. That is B is the right answer for the question number 8, that is 36.44 Newton per mm square. So now you can check the answers. So answers are also given here. Once again you can read the question and understand and solve the small problem and get the answers, and compare all your answers to these answers that I have given here. Okay, so this is about what the MCQs and solved question as well as MCQs. So here I have referred so many books pertaining to this video. That is the textbook of machine design written by R.S. Kurmi and J.K. Gupta, S. Chand Publications, Delhi. Okay, and also I have referred one more book, that is machine design by V.B. Bhandari, Tata McGraw-Hill, design data handbook, as well as DDHP, that is design data handbook, written by K. Mahadevan and Balaveer Reddy. Okay, so these are all the books that I have referred in preparing this video. Okay, so finally I am going to say my sincere thanks to LMS team. So that is Gopinath sir, who is the chairman of our automobile engineering department, and I would like to convey my sincere thanks to coordinator, that is Jagdish Bagri. He may be, I think he may be changed. Okay, Anil Bagare sir, that is LMS coordinator, and moderator sir, that is TP Chavan sir, for this subject, and our subject expert Shambhoji sir. I'm also I would like to convey my sincere thanks to our subject expert, that is S.S. Shambhoji sir, and other colleagues. They are called as other colleagues, like other content developers. I would like to say my sincere thanks to other colleagues and all the team of the LMS team. Okay, so for any queries, please contact me through my email. My email ID is like this: bhwmasenkrl@gmail.com, bhimsenkrl@gmail.com. Thank you for watching my video. Thank you.